So students, in the previous lecture we have learned about the first contact force, which was normal reactions. Okay, yes, so you have done many questions between, like you have to find the normal reaction with a surface or between two blocks. So we write our FBD rule simply. Okay, now in this lecture we are talking about next contact force, that's tension force. So second force we are learning, that tension in strings. Okay, yes. First understand what is tension force. Tension is a type of what? Intermolecular force. Okay, yes, intermolecular force. When you are trying to stretch a string, the string want to restore to its original position, right? So that force is called what? Tension force. And few important point about tension. Okay, yes. First point is what? Look at the direction of tension. How it looks? Direction. Like before this normal reaction we have just done, how the normal reaction looks. Suppose these are two blocks, they are in contact, then this apply force on like this way and this apply same force on this like this way, right? It's towards the surface, right? Now, yes, suppose you write FBD of, then how you write? You write like this, this is a reaction R, correct? So how you say this our normal reactions, okay, towards the surface. But here tension force, how it looks, suppose you tie this a heavy mass, you tie a string and you are pulling from here. Okay, you are pulling these strings, right? Then how you write tension? Away from the point of contact. Here write tension like this way. How tension looks? Away from the point of contact. This string is in contact here, so the tension will be away from that. Here is in person's hand, so it's away from the person, right? So tension force what? Away. It trying to restore the string. Suppose you are trying to pull that mass by string, so the string may extend, correct? No? Yes, because you are applying force. So this tension force trying to restore it, right? So it's always away from the point of contact. So what is direction? Always away from point of contact, correct? Yes, this is direction first thing. Okay, yes. Now second point, this tension may be same in a rope everywhere or may be varying. It depends upon what type of rope we have. So two possibilities we have. What to, if massless or you call it light, okay, string. In that case, if you have massless string, okay, or light string, then tension at every point will be same. Tension at every point will be same. Suppose this string is what? Massless or very, very light, mass is negligible, then tension at this point, that point, any point you talk, whatever full string, it will be same. But you have heavy, like heavy string, okay, yes, or yeah, which has what? Mass, then tension at every point will be different. Tension at every point will be different, right? Yes. So this is special case only, we will discuss at the end. Maximum time 90% questions will be based on what? Our massless string only. The mass of the string is negligible, so tension at every point in this string will be same. Here heavy ropes will talk, heavy ropes or heavy string where tension at every point will be different, okay, because its mass is what? Significant as compared to what other mass is, okay, yes, okay. So here how they ask questions, again same only, we have to find tension in the strings, we have to find acceleration of the system. It's exactly same like what you have done what? Last topic, normal reaction, we have to apply what? FBD rules. We have to find acceleration of system, which is net force by total mass, then we have to write FBD, 1 block, 2 block, 3 block, doesn't matter how many blocks we have, one by one we have to write FBD of everyone, okay. Let's understand with help of example first, okay, yes. Suppose this question is given to you, find tension in the strings and acceleration of system. This is a question, okay. And also again here we are still not talking about friction force. Without friction everything we are doing. Once we learn friction, then we will do all problems, the same problem like normal reaction, tension and all these with friction, okay. So suppose some block is given here, 10 kg block, or first we write as some general, suppose M1, another block is here of mass M2, okay, connected by a string, and this you pull by some force. Again you cannot push this system, yes, because string is there, okay. So you applied some force here, F here, right? Now there's only one string this here, so they asking what is the tension this string, let's call it what, name somewhat T, okay, EST, away from the point of contact always, yes, and these are moving in this direction with some acceleration what A, correct. So because I said this inextensible string, so if connected with two masses, then everybody should have what, same acceleration, everybody moves at same acceleration, right, okay. So let's find acceleration of the system first. What is acceleration of the system? Net force by what, total mass, same formula, same rule, okay, yes. So what is the acceleration of the system? Net force, we applied F force here, no other force here. Suppose friction is there, then friction will come here and here, it will be opposing force, so F minus friction here, but here we not talking about friction, so just F force we have applied by total mass is what, M1 plus M2, 2 block, 3 block, 100 block, same procedure, right. Okay, then we have tried to find tension, this tension we have tried FBD, you can write FBD of that block, your choice. Suppose you write FBD of M1 you writing, then how it looks? So rule, cut your body, put it here M1, correct no? Yes. Okay, here I can write one more separate heading because here string equations can be like body is moving horizontally or body is moving what, vertical also, right? Again two possible cases, yes, because last equations we have done normal direction, there is only one type of possibilities because only horizontally, you cannot move masses vertically because they are not glued, okay, they are tied by some string, they were just in contact only, okay. Again here I am saying in every equation there are two possibilities, either the system is moving at constant velocity or at rest, in that case net force is what, 0, Ma becomes 0 term, or accelerating like this, then net force is equal to what, Ma, you should not forget that, okay, yes. Okay, so what is the answer here? Here tension T is acting here and this accelerating in that direction, correct? This mass is what, M1, so here only one force acting T, so T should be equal to what, simply Ma, that's your answer. Acceleration already you found here, so tension is simply equal to M1 upon M1 plus M2 into what, F, that's what acceleration. Same answer you can get if you write FBD of this also, correct no? You try it. Okay, now check this. So this is a simple question, two blocks were given, you applied a force and accelerating, and for NEET this much is the only level, only friction they can give here, we will talk later. Okay, suppose now I give as a numerical to you, yes, first I am talking about like body is moving horizontally, so you can write, if you want to write pattern name, first you are talking body is moving horizontally, okay. Then we will talk about vertical cases also, when body moves vertical, then how we write answers, okay. Okay, let's talk few more example in which bodies are moving horizontally and we have to calculate tension and the acceleration of the system. Okay, let's see this problem. Find tension in string and acceleration of the system. So some picture is given to you. This is one mass, another mass here, and is pulled by some force F. Let's say this is 2 kg, this 3 kg, and this is pulled by what, 20 Newton force. Okay, and they are moving on a smooth surface. This surface is what, smooth, no friction here. Friction problem we talk when we learn friction. So smooth surface, okay. Here also, no friction we are assuming. Okay. So you have to find two equations, one, what is the acceleration of the system A and what is the tension in this string, right? Okay. Yes. Okay, let's find first acceleration of the system. What is the answer? A is what, net force by what, total mass, right? Yes. So net force, what is applied here? 20 Newton, no other force. Here you cannot write weight force because weight, M is acting what, vertically downward, and our bodies are moving horizontally, so you have to talk only about horizontal forces, right? Yes, and no friction given here, so 20 Newton is the only force acting, 2 plus 3, so this becomes 20 by 5 or 4 meter per second square. This is the acceleration of the system. Now you have to find tension in this string here, let's call that T. That you can find if you take FBD of that body or FBD of that body, your choice. That will be easier. So let's write FBD of 2 kg. FBD of 2 kg body. How it looks? This is a 2 kg body. Let's write forces acting. Here is tension T, acceleration this direction, no other force, correct? Yes. If friction was here, friction will act in opposite direction, so you can write F in this direction. So T is equal to simply ma, or T is equal to m is given 2 kg, acceleration we found as 4, so this becomes about 8 Newton. Same answer you will get if you use this as FBD. Let's try FBD of 3 kg body, right? How it looks? This is your 3 kg body. Let's write external forces. Here is tension T, and here is F, which is what 20 Newton given, and is accelerating this direction, right? Yes. Okay. Already I told you tension is always like away from the point of contact, right? Always away. While normal reaction or reaction will be always towards the surface, right? Okay, so let's write this system moving that direction, means what is the equation here? Net force should be equal to ma. T 20 minus T is equal to what? Ma. 20 minus T, m is given what? 3, a we have found here 4. Okay, so this becomes 20 minus 12 means again what? 8 Newton. Same answer we got what here? Thus here. So you can take FBD of this, FBD of this. Okay, this is 2 bodies connected, right? Okay, now suppose the given that this system is moving without acceleration. If they move at a constant speed, then your ma term will be 0, the acceleration will be 0. So all these forces like tension in this string becomes 0 if you move at constant velocity, right? Yes. Okay, let's see one more example. We talk about what? 3 bodies. So question remains same. Find tension in the strings and acceleration of the system. Okay, now we'll talk about 3 bodies. Okay, suppose 3 bodies are given like this way. This is one connected by string, another connected by string, okay, and we apply some force here, right? Okay, let's write this as 2 kg body, this as 5 kg body, this as what? 3 kg body, and say here 30 Newton is the force applied. Okay, yes. So this is a one string. Here you have to find tension. Let's call that tension as T1 name. Here tension, let's call it T2. And here they don't ask, but even they ask, let's call that T3, which is simply equal to what? 30. Already I told you. We'll calculate that. Okay. Yes. So T2 here. Okay. Again, they are moving on a horizontal surface, which is smooth. No friction is given. Okay. Yes. Okay. Let's solve this. First find acceleration of system, net force by what? Total mass. What is net force acting? 30 Newton, no other force, no friction force. Yes. Total mass 2 plus 3 plus 5, 30 by 10, 3 meter per second square. That's the acceleration of the system. Now we have to find tensions, okay? Yes. Let's take FBD of 2 kg body. That's the simplest. FBD of 2 kg. So I said that you can take this, you can take this, but right now you cannot take this because 2 things are unknown. You can take, but equation become complicated, 2 things will be unknown. So it's better you take this body or that body. Okay, 2 kg body you are talking, this is 2 kg body here. Let's write forces acting, here is tension T1 and accelerating this direction, no other force acting, right? So tension T1 is simply equal to what? Ma. M of this body is 2 and A we have found what? 3. So this becomes what? 6 Newton. That's your answer. You want to find T2, let's take FBD of this, okay, FBD of 5 kg. When you take FBD of 5 kg, how it looks? This is your 5 kg, what force is acting? This direction tension T1, here is tension T2 and acceleration this direction, right? So with this, which force is big? Always the direction which we are moving, that force is big. So T2 minus, this is T1, so T2 minus T1 is equal to what? Ma. T1 already we have found, T2 we need to find, so minus 6 is equal to M is 5 and A we have found what? 3, correct? So this T2 simply becomes how much? 6 plus 15 is what? 21 Newton, right? Okay, understand T3 will not ask, even they ask this string is same as what? This 30 Newton itself, right? T3, correct? If you're confused, let's take FBD of this body also and check whether T3 comes really 30 Newton. Yes, it should come. You don't need to calculate in real. FBD of 3 kg, suppose you talk. This is your 3 kg body. Here is what? Tension T2. Here is tension, let's call it T3. Correct? I should not calculate, still I am showing it. is useless actually. Okay, acceleration. So T3 minus T2 should be equal to what? ma. This is what 3 kg body. Okay, T3 minus T2 we have calculated, which is 21, is equal to ma, means 3 into what? 3, right? So T3 becomes how much? 21 plus 9 means what? 30 Newton. So you should not calculate, no need to calculate all this number, because this point is same that force only. Okay, in this string what is force? That 30 Newton, right? Yes. Okay. So these are the example when bodies are moving what? Horizontally. Now after this we will talk bodies moving in vertical direction. Okay. Yes. And you have understood that these all problems we are doing without friction. When friction will come, then friction force will come here. Okay. You will talk about them. And in this case, like system can be accelerating or the moving at constant speed, means not accelerating. Accelerating means we are writing acceleration everywhere, net force is equal to ma. If not accelerating, then directly if net force is equal to what? 0 simply, right? Yes. Okay, second topic we're talking here, like horizontally we have learned bodies moving horizontally on a smooth surface, then we have to find tension and the acceleration of the system, right? Now suppose they're moving vertical motion, okay? Body is moving what? Vertical motion, right? Yes. So when you talk vertical, then you know we have to talk about what vertical forces, right? So in that case now mg will come, weight of the block will come, right? Again in vertical we can have two cases, like first case they are just hanged, some blocks are just hanged, they are not moving, right? Okay, block hanged. Hanged means they are not moving, so A will be what? 0 first. Like suppose this question, some blocks are hanged from a ceiling. This is a block of mass m1, this is a block of what? Mass m2, right? These are just hanged, okay? Yes. So they have to calculate, we have to calculate what is tension in this string, let's call T1, and what is tension in this string, T2. This is the question, okay? Here acceleration is already 0, no need to calculate because they are just hanged at rest. So A time is what? Directly 0 first. And you have to calculate tension. So directly let's write FBDs of them. So if you write FBD of suppose M2, then what happens? Okay, you cannot take FBD of this because T2 and T1 both are unknown. You take FBD of this. Okay, yes. When you take FBD of this, how it looks? Vertically hang. So one force upward, that's what? T1. Then is what? M2. One force downward, that's called what? Your weight, M2G. And this is not moving, they are at rest, so it's not accelerating. So T1 force simply equal to what? M2G. That's a tension in the T1 this string. So this string supporting what? That much weight itself, right? So that's a tension in the string. But you see that string is supporting this weight plus this weight. So tension here should be equal to weight of this block plus weight of this block. That will come. Let's see. Suppose write FBD of now M1. Then what will happen? This is your M1. Upward force is what here? Tension T2. Downward force is what? One is tension T1 and one is weight of this block, that's called M1G. And this is not accelerating. So again these forces should be equal. So T2 should be equal to what? T1 plus what? M1G. T1 already we have calculated, which is M2G. M2G plus M1G. So this becomes simply M1 plus M2 into what? G. That's the tension in the string, because this string is supporting these two weights, right? So tension is what? Weight of these two blocks, but this string support only this much weight. So M2G is the tension in that string. So this is very simple when they are not moving, correct? Okay, suppose we talk now about motion, they are accelerating, okay? So let's write the case, blocks accelerating upward. They can accelerate upward, they can accelerate what? Downward also, right? So first let's talk about, suppose this block start accelerating upward, then what will happen? Okay, so because to accelerate upward we need to apply a force. To hang we don't need to apply, just hang from the ceiling. So this is block M1 and this is same block M2, correct? And here we have applied a force so that they are accelerating upward. Okay, here let's call tension T1, right? Yeah. And here force applied, let's say how much force applied, any force applied F, right? Yes. We have to calculate what is the acceleration of system. Suppose they are moving upward with some acceleration A, right? We have to calculate the acceleration of the system, then we have to calculate tension in the string. There may be two block or one more block, okay, here. They can ask tension in this string also. Already I told you that in this string tension will be simply F only, right? Because they are at same point of contact. Okay. let's calculate acceleration of the system first. Okay, here there was no acceleration, here there is acceleration. So acceleration definition is same only, F net by what? Total mass. Right? Everywhere we have to use same rule. So acceleration is what? What is net force? One force applied is what? F, which is moving these bodies upward. Then who are the opposing here? The weight of these blocks. In horizontal motion, the weight of the block did not came because weight was downward and we were moving horizontally. But here you see that they are in one direction, force upward and mg was downward. So the weight of these two blocks, they are trying to oppose this motion, right? So force is causing the motion upward and these are trying to stop. So this is a net force by total mass what? m1 plus m2. This is the acceleration of this system first, okay? Yes. Now we have to find tension T1. So write FBD of the m2 block. So FBD of m2 we writing. So when write FBD, how it looks? This is your m2. What are forces acting? Upward is what? Tension T1. Downward is your weight m2g. And then the acceleration of what? Upward A. Correct? Let's write for this, net force is equal to what? Ma. In vertical direction we are writing, so it should be equal to what? Ma. So which force is big? T1 is big because we are moving upward, let's say. So T1 minus M2G is equal to what? M2 into A. Or tension will be equal to what? Simply M2G plus M2 into what? A. Like A already we have calculated here, right? Okay, so that value you can put here. T1 is equal to what? M2G plus M2. When you put A here, watch carefully, it becomes like this one, F minus M1G minus M2G by what? M1 plus M2. Clear? Yes. So this acceleration, when you solve this, what will happen? Look here, M2G term is there already. So when you multiply this term here, right? Okay, we don't need to multiply, just keep this much only, right? We can say this much. Yes, if numerically values are given, that become more simple, just you have to put your value, that's all, okay? Yeah. So, okay, now let's talk third case. Suppose they are accelerating downward, C case, okay? What I am writing here? Blocks accelerating downward. Suppose this force applied is what? Small force, so that doesn't move up, still the blocks, these weights are heavier, so they move what? Downward. Then what will happen, right? Let's see them. So these are the same blocks, M1, M2 here, and you applied a force here, F, but they are moving downward this time, they are accelerating what? Downward. Again we have to calculate tension here, let's say it what? T1. Okay. Here you see, suppose acceleration directly given to you, then this is your direct answer, right? Yes. Suppose force is not given, that F is not given, unknown, directly acceleration of system is given to you, then this is direct answer. You can also write like what? You can take M2 common, M2 G plus A. Maximum time you have to answer like this. If force is given, then you have to put A value. A value already you have calculated here, just you have to put here the A, right? Okay. So don't confuse that this is a little long equation. No, I'm just putting A in terms of these symbols only. Otherwise, this much is the only answer, right? Okay, let's come on this side. Okay, let's find first acceleration of the system. Okay, now this system is moving downward, give attention. So A net will be what? Which forces are bigger? Because they are moving downward, so this weight forces become bigger. So it becomes M2G plus M1G. These are downward forces minus what? F by M1 plus M2. Here they are moving upward, this force is big, so I wrote this minus these forces, right? But here it's moving downwards, so I wrote it opposite. These forces are big, weight forces are bigger, minus F by total F1. Okay, same procedure, you write FBD of what? This block, FBD of M2 you're writing, okay? M2. Let's write it. So what will you get answer? This is your M2 block here. And what force is acting? Tension T1 upward, acceleration A is downward, then what? M2G is what? Downward. So if you see that this force is big, so I'm writing M2G minus T is equal to what? M2 into what? A. Okay, so tension becomes what? M2G minus M2 into A. M2 you take common, G minus A. Look at this answer. Tension is coming M2G minus A, right? What came here? G plus A. When you are accelerating upward, the net force become like this, G plus A. Same as your lift problem only, remember? Lift was accelerating upward, your apparent weight became mg plus A. And when lift was accelerating downward, became mg minus A. Same is coming here, right? Almost same. Okay? Okay, let's do some numerical practice on these, okay, now. Right? Okay. Okay, let's see a numerical example on vertical motion of the blocks. Okay, so find tension in strings and acceleration of our system. Okay, some picture is given to you. Some blocks are there. This M1 block, M2 block, and what M3 block. Okay, and we applied some force here. Let's give value also. M1 we say is what 2 kg, and M2 you say is 3 kg, and M3 let's say is 5 kg. These values are given, and from force applied here, let's say 200 Newton, or this big little, so okay, 200 will work. 200 Newton. We have to find tension in these strings. Let's call T1 here. Let's call T2 here. And T3 here also, okay. That is direct answer, we know is 200 only. Still, let's calculate this. Okay, and this whole system is moving what? Upward with what? Acceleration A. Okay, it can move downward also, as we have discussed already. Okay, first you have to find the net acceleration of system A, which is said net force by what? Total mass. What is net force applied here? 200 minus the weight of the blocks. 200 force is trying to move the system upward, and the weight are trying to stop or move it what? Downward. Okay, so it becomes simply m1g minus m2g minus m3g all divided by total mass m1 plus m2 plus what? M3. Okay, 200 minus m1g 2 kg, so it becomes 20 Newton, that becomes 30 Newton, that becomes what? 50. So minus 20 minus 30 minus 50 by total mass become 2 plus 3 plus 5 means what? 10 kg. So this becomes 100 by 10 means what? 10 meter per second square. That's the acceleration of what? This system first, okay. Now we have to find tension, so you have to take FBD. So we will take FBD of first this body because T1 is only unknown. So FBD of which body you are taking? Third mass or M3 or your 5 kg body, right? So let's cut and put 5 kg body here. This is a 5 kg body here, okay. Just write like M3. And what upward force acting? T1. What is downward force acting? Mg, M3 into G, and accelerating upward A. Correct? Okay, they are moving upward, so this force is big. You say simply T1 minus M3G is equal to what? M3 into A. Net force is equal to what? MA. Okay, T1, M3G we know, mass is given what? 5 kg, so it become what? 50 Newton. Then 5 into acceleration given 10, so this also becomes 50. So T1 becomes what? 100 Newton. So tension in that string will be what? 100 Newton. Same formula only like M3G plus A. Correct? Yeah. Okay. FBD of M2 block. This block's FBD, right? How it looks? I'm drawing it here. This is your M2. Upward force is what? Tension T1 or T2 we are writing symbol. Yes. Downward force is what? One tension T1 plus weight of this block M2G, and it's accelerating upward. Correct? This is the FBD of this block. Okay. T2 minus T1 minus M2G is equal to what? M2 into A. This net force is equal to what? MA. Right? Okay. T2. T1 already we know is what? 100 Newton. Clear? Okay. Then minus M2G. M2 means weight is given 3 kg, so it become what? 30 Newton. M2 into A. 3 into what? How much given? 10. This also become 30. So T2 becomes what? 160 Newton. Correct? Okay, T3 we don't need to calculate. It becomes 200 only. Still, if you want to try, you will check it. Take ABD of this block. Upward force is T3, downward force is T2, and what? M1G, and accelerating upward. Write that equation, calculate, your answer should come what? Exactly 200. Okay. In exam we don't need to calculate. We know that this force will be same that force only. Okay. Yeah. So this was example on what? Accelerating in vertical direction. It can be accelerating upward or accelerating what? Downward. Okay. Now, so we have done two type of questions on strings connected, blocks connected by strings. Horizontally they are moving, or they are moving what? Vertically. Now we talk about an incline, third type of equation. So motion of blocks connected by string on incline. This is the third type of equation. Or okay, yes. So incline, like we have done for normal reaction, right? Same we have to do for tension also. So first we talk simple example like blocks at rest. Okay, block at rest, they are not moving. Then we'll talk accelerating. Okay, so blocks at rest means how they will look. Suppose this is some inclined surface, angle is what, theta, and one block is placed like this way. This is a block placed M1, and they are asking what is tension in this string T. There may be one block or two block, we'll talk. Okay, yes. So in this case, what you have to talk, acceleration is already 0, we no need to find it at all, right? We have to say what is just tension in this string, correct? So you take FBD of this M1. When you write FBD of M1, how it looks. This is your inclined surface, this is what your mass M1. Okay, tension T in this direction, and downward is a weight component, which is what M1G sine theta, right? This thing you know that the weight of this block along this incline is always what, mg sine theta, right? Okay, so in the non-accelerating means here simply T is equal to what, M1G sine theta. That's your answer. There's a tension in the string, done. Correct? Yes. There may be two blocks. If you write one more block here like this, where then tension T2 you have to calculate, you can take FBD of this first. Same procedure. Tension T2 upward M2G sine theta downward is equal to what, 0, because not accelerating. Okay. Okay. Suppose it's accelerating, then what we'll do? Okay. So second case I'm taking blocks accelerating. Okay. Okay, accelerating means you have to apply some force. If you want to accelerate upward, downward they can accelerate, no problem. Okay, I got one important point about this motion vertical blocks. Okay, let me do it here first. Suppose these blocks were hanged by a string at rest. Okay, like this one. Very, very important point to write about vertical motion. Suppose they are hanged by vertical, some blocks are there, M1, M2, they were hanged. Then they say that I cut this string. I cut this string, right? You cut it from here, then all blocks will fall freely, correct? Na? So what is the acceleration in that case? What is the answer? G. And what is the tension in the all strings? What is the answer? 0. Tension will be 0 if you cut this. Okay, so write a very important point about vertical motion, that if strings are cut from here, they will freely fall. In that case, acceleration becomes what? G, simply. Okay, if that's what is the acceleration of any block, doesn't matter how many blocks you have, it will become directly G. Then there is tension in the string here, T1, T2, or any number of strings you have, T3. All this tension T1, T2, T3 all becomes directly what? 0 if you cut a string and freely falling, right? Na? Okay, let's come back here. So I am saying blocks are accelerating. Okay, so same thing, this is your some waves or inclined surface theta, and these are the blocks, block M1, block M2, right? And we applied some force here, F here, so that they are moving upward. We have to calculate what is the tension in the string here, T1. Okay, yes, let's call T1. Yeah. Okay, so same rule. First you have to find acceleration of the system. Now they are accelerating, you have to find acceleration of the system. Then you have to write FBD. So what is acceleration? F. Net force is what? F is upward and the weight are what? Downward. So F minus M1G sine theta minus M2G sine theta by what? M1 plus M2. That will be the acceleration of this system first, right? Yes. We are talking forces about along the inclined surface. So this force along the incline, so the weight component along the incline becomes what? Mg sine theta, right? So this force is trying to move them upward and the weight is trying to drag them down. So net force is like this one. This is the acceleration of system. Now same way you write FBD. Suppose you write FBD of M2, how it looks? FBD of M2. This is your inclined surface. This is your M2 body. Downward force is what? Your weight component M2G sine theta. Upward is what? Your T1, and is accelerating this direction with acceleration what? A. So in this case, what is the answer? T1 minus M2G sine theta is equal to what? M2 into A. That's your answer. Okay. Yes, acceleration already calculated here, so you can put it here. That's your answer. Same way you want to find tension here. Already we know, like suppose the T2 is will equal to F2, but you can take FBD of this. You will get what? F exactly. Okay, so there are two possibilities again, at rest or accelerating. We can accelerate downward also, okay, doesn't matter. Even you apply the force F here, they can they can accelerate downward, doesn't matter. They moving downward means these forces are big. So when you write acceleration, you write m2g sin theta minus plus m1g sin theta minus F you will write. So whatever direction is moving, we saying that forces are big simply. So that minus opposite force by total mass you have to write. Okay, let's do a numerical example on this. Okay, problem we're doing, find acceleration and tension, right? You can write something in the given problem. So some problem are given, this angle is given 30 degree and there is some blocks, there is one block here, there is one block here. Let's say this is 2 kg block, that I write 3 kg block, and we applied a force here. Okay, let's say how much force we applied. So how much force I write, F is equal to suppose 12.5 Newton is applied. Okay, some force is applied. How much force applied? 12.5, and they are accelerating upward. We have to, okay, I wrote the force little small, so I should not write, I should write, let's write 125 Newton. Okay, 125 Newton's force applied here, and they are accelerating upward, 2 kg block and 3 kg. We have to find what is the acceleration of the system, and we have to find what is tension at this point, okay, in this string. Okay, let's find acceleration of system first. So acceleration will be what? Net force by total mass. Force upward is what? F minus m1g sin theta minus m2g sin theta by what? m1 plus m2. So F is given already 125 Newton. m1g, okay, m1 is, let's give name this m1, this is what m2. Okay, what is mg first? 2 kg given is 20 Newton. Then sin 30 means 1 by 2. So 20 into 1 by 2 become what? 10 Newton. This is 10 Newton. Same 3 kg means 30 Newton into what? Sin theta become what? 15. So this becomes what? And m1, m2 is 2 plus 3. So this becomes 100 and this becomes what? 5. Okay, it's coming very big, but I just wrote values. Okay, 20 meter per second square. Okay, yeah, this is the acceleration system. Now you have to write FBD of this block to find T1. So you're writing FBD of that M2 block, 3 kg block, this block I'm talking. Okay, this is your inclined surface and this is your 3 kg body. Yes, 3 kg. What force acting upward is what? Tension T1. Downward is what? Your M2G sin theta component, and accelerating what? Upward. So this force is big, so you say T1 minus M2G sin theta is equal to what? M2 into A. T1 minus M2G. What is mg? 3 kg is 30 Newton. Again sin theta becomes what? 15 Newton is equal to 3 into acceleration we found what? 20. So T1 becomes 15 plus what? 60. That becomes 75 Newton. Okay, this is the acceleration. Right, so these are all type of questions. Once more I am revising. The motion of the body is connected by a string. They can move horizontally, they can move what? Vertically. Again, in every case we have two possibilities. Either they are moving at constant speed or at their rest, means acceleration will be 0, or they are accelerating, right? When you talk about vertically, they can move accelerating upward, accelerating downward, or at rest, or it can be cut. When you cut the string, the acceleration of the whole blocks becomes, or whole system becomes g only, and tension in every string becomes what? 0. Correct? Or last case is what? Inclined type of problem, right? Inclined surface. So these were all about what? Motion of the body is connected by what? Strings. Now again strings only will talk, but with pulley we will talk, okay? That we'll talk in next lecture. Thank you.